So last stream, we basically got at this plan, if you about how to logic do layered materials, and it seems like it's gonna work. I think start off with oh, layered material. We had have to go to, so let's see. Oh, past me. The deeper it is. So we got these. So gotta find out how do you do like mappings. Decided to do like the because they're 3D textures. RAM is gonna be up. But so we've got this, and this margins. How we're able to do 128 bits. So the idea is now is shading part. Could have done a shader code. So the got to try and know, can we, rather than having like tons of specialized, have ways of like finding some materials. So we could probably, hey, we like the way the brick looks, but stones on them. Or, hey, we like. How do you? How do we? Hey there, Ultra. How you doing? Oh no, that's not very. Ah, thank you for talking. Hmm. Right, is that coming up now? Maybe. Maybe. You know what? I think my son has came buttons. Okay, so no, this one? Maybe not. Okay, is this better? No, is that better? No. Okay, going. No, no, no. Don't know what's going on now. Oh, it's fine now, is it? Right, how is that now? Is that fine? Bit quiet though. It used to be a bit louder. I can remember it being a bit more up here. Right, strange. Hmm. What about these things? If I keep twisting this, is it going to change anything? Right, so. Hmm. Alright, it's fine then. Yeah, I pressed a button. It got. Okay, maybe not. Hmm. Alright. I'm not going to press anything, and we'll just carry on and see what happens. Right, so the basic idea is in layered materials, and we're going to have 4 different slots, I think. So we've got these geometry materials, and the basic idea is, say, if you have a mesh, I think it's mainly for cuboids. You can basically ray march into the cuboid and change completely how the geometry is. That's what a geometry material is to completely change the geometry. And maybe it could work for non-cuboids. Sorry. Yeah, it can work for non-cuboids as long as we provide some kind of vectors that go around it. So it could be like as long as the cuboid shape inside each space, where it's going from -1 to. Cool. So that's what geometry material is. The next slot would be a detail material, and this is what we was trying to figure out last stream, and it was really difficult. But I think we got it nailed now. So with this one, um, we tried to do this moss the other day, and so the thing is, we've got essentially like grids of moss balls, if you will, and I wanted to try and find a way of how do I sort of get rid of the balls that are not kind of intersecting with the shape underneath. And the way I've thought about doing that is we probably want to have a general system called a detail material. And essentially, it's going to try and procedurally place down bounding spheres based on some generic settings on how many grids of things and how much they repeat type of thing. And they're going to be. There's a way I can draw it. Yeah, so here's your surface. Here's your UV space. Yeah, your texture space -1 to 1. Here's your box. And then here's the surface because we've pushed it in by a certain amount. And the idea is you want to be able to spawn blobs of moss on the surface somehow. Right, but not allow them to come out of here such that if you look from a different angle, you will see it. And yeah. What else? And yeah, not allow them to be detached from the surface as well. Right. So basically how we're trying to solve this problem is we're going to have these we're still gonna have this sort of grid of of moss, if you will, and it will go at different and they can have different sizes and stuff, but the basic idea is there'll be bounding spheres. And when we do our ray marching, we first ray march against the surface to try and find the surface, and that'll be the geometric material. Then we do the detail material. So this time will be the moss. And when we ray march, we'll find some along the way, test against it at the center of the sphere. How close is it to this surface here? If it's further away than the radius, then we will ignore it and carry on until we basically find a sphere which does collide. So this one doesn't. This one again doesn't. This one here does. That means we'll accept this one as a candidate to be marched into, basically. So we can always have detail. That means we should be able to make volumes of things that fit into a bounding sphere. We can have a bounding sphere, and maybe it's just a piece of moss in here, so it's like I don't know, just something like that. Obviously, it would be more perfect fitting. And they'll be all over the place, and we'll also support maybe, some grass or something. But we've got to figure out, like, how do we orientate those the correct way sometimes, or maybe it might just be a stone, right? And you have different stones and things like this. Each sphere can house it can be changed based on some kind of seed as well. So that means we should be able to add, like, literally paint on detail with this system, which would be quite cool. I was thinking moss or some dirt or stone or some kind of ore, basically. Yeah, and the final layer type, if you will, is a blend layer, right? You might just have, you might not want to change the geometry at all. You might just want to change the shade, change the material properties directly. So some kind of tinting, or I don't know, just some kind of extra code that runs that changes the material properties. So that would obviously just paint over it, and yeah, they just run at the end. And they could maybe be based on some kind of height value. It's not really a specific height, but it's just some kind of threshold, basically, to sort of say this blend layer wants to be between this threshold on this material. And yeah, so we can paint stuff maybe on the in between the groove, or in this sort of cement layer, or maybe just around the edges of the bricks, right? So there should be these sorts of options available. So this is what we're going to try and pull off over the next couple of weeks, probably, because we want to get some different materials to test out as well. But yeah, it's going to be fun. So hopefully this all pays off. So today we're going to start off by doing a little bit of the refactor by refactoring out the ray marcher of the geometry materials into their own into a function that we can call, basically, because we want to make sure that we can do ray marching at different resolutions. So we want to snapshot this out into its own thing, basically. Hey, Putrafazzo. Oh, wait, you're a Christian. That's cool, man. I've been seeing your channel on here on the list, but never thought that'd be you. Cool. Yeah. Well, yeah, I just came back February, so I've only been back like come up to 2 months now. But yeah, I've always been like not always. So for the past like 4 years, I've been like a kind of, getting into the faith and learning and not really reading my Bible that much, being kind of like a lukewarm Christian, eventually accepting Jesus, but not really um, being all in, right? Just getting more and more basically until it kind of hit a point last year where I was like, you know, um, just decided to get really serious about it, had my own encounters and things. Um, so yeah, I've been given some tasks to do by God now, so getting really serious about it basically. How long you been a Christian for by any chance? Yeah, so it's been really cool, you know, God has been really patient with me, and I've seen how much of a fool I've been, and how much of a terrible person I've been as well. But you know, um, life is really different when you really, really believe and do want to do God's work well. And yeah, so I've decided to like, I think this thing that I was doing before was a bit of like my idol, if you will. So I've like reorientated it now, around God. So it's not really an idol anymore. I try to seek God first in everything that I do. Sometimes fall short, of course, but yeah, like I try and read my Bible as much as I can and memorize things, and you know, try and realize how much I fall short still. um, and yeah, try and just surrender my will to God's will as much as I can. Oh, amazing! That's really cool. So, yeah, as long as you can remember, so like since birth, you've kind of your parents have brought you into it, and you've always felt like, oh, yeah, that was the right thing. Yeah. This year I decided to be a real Christian, like fight against sin, stop speaking curse words and so on. Yeah, 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 I get you. Yeah, yeah, nice. Yeah, yeah. I think, yeah, last year as well was about the same. Last year was for me, that sort of thing. It's always funny how we think we're good, for a long time, especially like in today's age. People can really think they're a good person, or they're a wise person, smart person. But when you really like dig deep into the Bible and you know, take a look at yourself and things, you realize how bad you are, how many bad things you do, um, and really sometimes and how much you hide it as well, you know, and also how smart you think you are, how much pride you have that you carry around, but really like under God, you're a complete fool, right? And really, you know, um, yeah. So yeah, it's really humbling, put it that way. Um, but yeah. But yeah, we're all thankful for God for, waking us up, and it's our job just to help other people get there, isn't it, really? Um, the best we can. Yeah, so one thing is we've got this sort of procedural material, sorry, prototype material, if you will. And so these are like basically a shader code with parameters, and then the material is the arguments for a proto material. So then, like, if we've got different classes, right, different kinds of procedural materials, right, we've got a geometry one, we've got a detail, and a blend. We've also got problems of like, um, these are IDs, and you kind of want these to stay the same. No, I don't think you do. Uh, yeah, maybe we'll have a 2-bit thing. think this will be it. Kind, geometry, detail. Gotta go. Definitely stop by soon. Take care. Thank you. You too, sir. Have a good day. Appreciate you coming by. Right, detail, then blend, obviously. Hey, Dowsy, how's it going, sir? How are you? Good evening. How you holding up? How's the family? Good, thank you. All well with you? How's the family? Awesome. Yeah, doing good, doing good. Yeah, I guess I could break some news today. Maybe. Yeah, screw it, let's do it. So, yeah, things are doing good. You know, it's my birthday the other day. You know, I'm now, as the date is, I'm 31. So I'm now creeping into I'm creeping into my 30s a bit more. But also, uh, you know, the Lord has blessed us with another baby. We've got you know, my wife's now pregnant, and well, another one coming. Yeah, it's been a real big struggle. You know, I thought having children was easy. You know, you just do the deed, and they just happen. But you know, um, I've been humbled. uh, man, yeah, I've been humbled. They don't come that easy sometimes. Been a bit of a struggle, this one, but this one seems like it's, you know, seems like I've got this one, which is amazing. You know, but yeah, so super happy. Not sure what it is yet. We're gonna go for a second scan soon. It's coming up. Yeah, it's gonna be amazing. Procedure material, a geometry. Geometry material. Yeah, you know what? So I think we might stick in there the kind in the higher bits. Yeah, I'm not sure. How is this even passed up? There's like a geometry. So graphics VK shared. I don't know. Yeah, graphics VK shared encode on that one. Right, it says 8 bits. 24 bits for the property. Okay, so we'll store the kind in a separate thing here. That would be good. That would just be 2 bits. Okay, so then I think we can have a geometry index. Geometry. What's a geometry material index? So that'll just be. So raw might be. Do we need a raw one? So if you just want to provide like basic material properties, that's what that one was basically, raw. It's like a solid color basically. Fabulous news. Thank you. Thank you. Yeah, it's going to be awesome. Can't wait. Speaking of which, I've got to get the baby monitor. BRB. there we go. So when you have like a raw, so a detail, I guess that'd be a detail layer. Yeah, I guess that'd just be a detail layer. So raw doesn't have to go. Yeah, so it's detail. A little bit the wrong way around. So the moss layer. Oh, sorry, it's called blend, isn't it? Blend proto material. Moss would be the detail one. Okay, so got one of each now. Amazing. Right, Serbia 0. Lovely. Lovely. Yeah, that's more like it, isn't it, really? Right, so detail, pro material, and the final one will be blend. So these are the three different kinds of materials for now. Maybe there'll be more, but I think that they're just going to be three. Okay, so awesome. Now the next thing to do would be, so from the CPU side, should we do the CPU side code here or the GPU? Let's write the GPU first, because otherwise we have to change some things. So graphics materials is where it all goes into. So this Raymarch, so graphics, geometry, material, Raymarch. Lovely. Do you get this sort of like M material for the GPU? So that would then be, so in this case, we probably would like to have the geometry proto material index. And then we'd like to have a word start index for the arguments that are passed in, basically. So that this will be received outside. Gotta find where to do it. Put it here for now. Okay, so well, actually we could, like, we know where the geometry material is, it's always in 0. So actually, yes, where's the shading structure? So we just got one material. Yeah, so we're gonna have the 4 layers. So the 4 layer, it'll just be 4 layers like so. Material layers. There we go. Now, so effectively, slot 0 is always, or material layers we'll call it, I guess. Yeah. So so define graphics VK material layer index. Now what does this material layer index do? manage. Yeah, so we don't have enums, so this is the way we do it. So the first layer is the geometry layer, right? It may or may not exist. Then you do a and that'll be the detail layer. And then you do a blend layer 0 and a blend 1. Cool. So yeah, something like that. Can't be 4. So I guess when we do that magic number 4 that we saw, that's in that shading structure. That'll go here, okay? So now, okay, so geometry material remarch. So you pass in the shading structure, it just has everything in there. So we effectively want to grab that reference, if you will. So we'll just call it MG. So that'll be shading dot material layers. Then we just want to have the geometry layer. Now, if we do not have a geometry layer, then we probably just want to return, I think is the... So how do we do that? So we have MG, let's call it M actually. We have M dot bit filled 0. So we could say if all of them are 0, right? So that would mean, how would that be, how would that look? So we go to the encoder file where these are declared. So graphics VK material GPU, this is it. So it's got some proto material index, so like basically what subshader to run. That's 8 bits. We got up to 256 for each kind. And then what is the kind? That's 2 more bits. And then we've got 22 bits for the properties, so the arguments for the material basically have some U32 word buffer. So yeah, if this fits into one U32, so if it's 0, then what does that mean? It's a possible thing, right? It's a possible option for it to be 0. But it's extremely unlikely and probably impossible for it to be U32 max. So that's the invalid value we're going to check. So maybe you say, maybe you make it a constant. We could do that. So graphics, oh. So in the encoder system, we do have support for constant expressions, so we could do that. It's because otherwise defines would have been a bit weird. I just called it constant expression. We didn't have U32 max though. Let's see if that wants to work. If it doesn't want to work, we'll just put it somewhere else. But it's nice to put it next to it if possible. There we go. So if it's invalid, we shall return. Just return. Nice. So now I want to extract out the... You know what, we don't need to have the kind stored in there, do we, thinking about it? you don't need the kind because you know based on what layer it is, what kind it is. So actually that doesn't need to change whatsoever, which is cool. So now we get out these two things, switch on this. Now we only have one. It's called a geometry material brick. Cool. And then we can get rid of A. Oh, did we not have a break? You know what that meant? Our brick was running a bit of moss afterwards, but it wasn't. I'm confused. But anyway, we'll remember to break because that's silly, right? Anyways. But yeah. We could define. We could do a define here. Maybe. No, let's just leave it like that. It might be nice if we did it like this though. So we'll call it enum function. Enum function. Do we do case? Undef case. Nice. Rightio, so the next one would be, yes, that's nice now. So geometry material Raymarch. So then we probably want to change this name now to be something else perhaps, and we should probably have different sections in this file. Yeah, just put it all in one file. So you want geometry material brick, and this one will be a blend material raw. So I want to move this one below the brick since they're not in that order anymore. So that'll be, there's the moss one. We need to change the moss to be also known as a detail material, which is going to work a bit differently, but we'll sort that out. All right, so what we got here? So we want the geometry material distance brick setup. So it just sets up this distance brick structure based on this. This is the distance function that gets ran. Right, hopefully it's not going to cause us problems later, we'll see. Here's the Raymarch brick function. It just does the Raymarching for the bricks. Then here's the shading code. So once you've hit the surface, how do you shade it? So we've broken them up into separate steps now such that we can Raymarch at lower resolutions. This code still has to be adjusted for that and possibly find ways to generalize it a little bit more. But it's just our first one. So there we go. Detail material. We need to rewrite this for this detail material thing where it's just going to be a bunch of spheres. Right, so here's your mesh. These are this is the mesh, the outside. This is the surface when we've pushed it in. And the detail material is basically a grid of spheres that just sits over the over this UV area, this material 3D volume, and every time we ray march against it, and every time we hit one of those grid of spheres, we check from the center position the surface of the material, and if the surface of the material is less than or equal to the radius of the bounding sphere, we can ray trace into that volume basically. So that means we can make lots of lovely little bounding spheres worth of things. So maybe you have a lovely little moss island in here, and it's a shader just for generating a 3D volume of moss. And this yeah, then the shader can have a different seed such that the moss can be different across the whole volume. And it can also support maybe stuff like grass as well, but we'll have to sort out the orientation. And how do you sort that out when you splat them onto the surface? But we'll see. We'll see how it goes. Stuff to work out as we go. Right, so I'm going to leave this one alone until we get to it. But maybe we'll comment it out for now, I don't know. Let's just leave it going for now. So, blend material, shade. And that's just the raw one, so you can just pass in the raw, diffuse, specular, emissive strength, gloss, and AO. Raw values like a solid color, basically. Cool. So, geometry material ray march. There's our guy. The next one would be material shade. So, this is probably... So after we've found our hit, now you know what? This is actually just going to be called material ray march and material shade. So we'll do the geometry material first. And then after the geometry material, we'll do the detail layers and see if we hit those. We'll add that afterwards. So we'll put a to do here to do detail material. Right, see if we hit the detail material before the geometry. Something like that. Right. And another thing we probably want to support as well is a geometry material distance function, maybe. Maybe we'll come back to that. Right, so in material shade, I think what we'll do for now is we'll just shade with the geometry material. Yeah, so we'll just slap a to-do in here. To-do shade with detail material if that was hit instead of the geometry. Right. Okay, it's looking better. So we do ray march and a shade. So we're going to go into the shading pass. Yeah, got to go into scene shade. And In here, yeah, where are we sticking these layers then? Are they okay? We're going to the mesh instance packed, whatever that is called. Right, so material, right here we are, so they're the layers. So maybe we do put the enum in here. Enough for dinner? Alright, cheers popping by, Dowsy. Have a good yeah, have a good rest of your evening, and I'll see you soon. God bless you, sir. So I think there's yeah, maybe we take that enum and move it into here because there's 4 layers and nice to see it in here, right? So VK shared dot H. So this guy. Well, I guess this is one way to make enums work on GPU. I just put them inside the code gen. That could work. Anyway. Nice. So the count goes here. Cool. Right, so we've got these layers that need to be passed up through the material now. So when we do the scene shade, so we've got the visibility, the layered visibility buffer. So we go over each of the layers and we grab the triangle instance ref. So I could probably just call it an object. I don't know. The triangle instance is probably fine. So it's an instance index and a triangle ID. We fetch the instance and then we try and, I've got to do the whole very centric stuff at some point, but yeah. Anyways, until then. So where we used to pass in the material here, we just got to pass in the 4 material layers. So what might be good is if we I could hard code it. I guess so. So material layers, geometry. All right, so right, there you go. So you just set all those in there. So that's all plumbed through there. The next thing would be from the CPU side, we would also like to sort this out, these different kinds of materials. So that would be right. So you've got these things called proto materials. Now I guess we could move them around in this folder. So we could say geometry. Yeah, let's just add another folder. Why not? So geometry. We want to do geometry, detail, and blend. There are 4 different kinds. So your raw is a blend. Your moss is a detail, and your brick is a geometry. Lovely. Now, interesting. Yeah, maybe you could actually. I just thought with the blend layers, you could literally paint on transparency if you wanted to. Huh, kind of interesting. Yeah. Anyways, might be quite powerful. So, right, so we've moved those around, which means we've got to move the, or sort out brick dot C or whatever it is. Where's the, so graphics dot C, yeah, so we do some stuff here basically. So you got your raws, which is your blends. You got your geometry, and you got your detail. So let's sort that out as well. Let's take these with us. Right, so these are your .h's there instead. Right, we'll generate it when it gets generated. And the cool. Awesome. So now from the CPU side, we've got to maybe change the material cache. So the material cache effectively just allows you to basically say like, hey, I've got this new material, find a slot to use, right? Get back a pointer and then like fill in the arguments for that specific kind of material. And yeah. So there's an array. So there used to be one, but now there's three different kinds, right? So, yeah, I was thinking, yeah, the way we've done them for now is there's like a name for them, and that name cannot change. And that's the identifier which is stored within every asset which references a material. But I think there might be another way of doing it. We'll find that out later on. So for now, I think we would like to just duplicate these. Geometry detail blend. So there's three different kinds now, and we just got to split up these effectively, right? Didn't work out exactly as planned, but okay. So the raw is going to be a blend. That's a blend. The brick is a geometry. Then the moss is the detailed. Right, and then we just simply have to use in the right place as well. So blend. Okay, so cool. Right, so what else we've got to change, which does make sense. So you can get a name, a hash of a name. Yes, I think you store the hash of the name in the file. Again, yeah, I think we might change this in the future, but there we go. So we want to have 3 of these guys such that it can just pre-hash the name up for you. So again, geometry, detail, blend. Nice. So all we're looking at doing is simple. Something like this. But then I'll actually drop that there. Yeah. Nice. Right, so what else do we need to do? So when we initialize this material cache, right, so it's just a pool of materials and the material structure, but just basically holds like, can we find you one? So yeah, it just holds a range block. So this is like a heap allocated range of property words. So word is a U32. They're just a bunch of arguments basically stored as U32 so we can reinterpret them on the GPU when we get to the other side. Name hash is the proto material index and what is its reference. So we're probably going to need a kind, I think. I don't know though. Maybe not. So we want to know index from proto material name map. So I think you want to just grab all of these guys and then add them up. I think. And then this one's going over all the pro materials and figuring out how big their properties are based on. Yeah. Hey there, Harry. How's it going? Welcome, sir. How you been? All right, so the problem is this used to be one index, now there's 3 different kinds of these. So yeah, you probably have one for each kind. Okay. Name hash is new. Right, so yeah, we probably want to just do this plus that plus that. Right, so bit long. Right, probably showing that to proto materials count, something like that. So you probably want to have one for each kind, I think. It's in the cache. You want to have an array based on the kind. So graphics BK proto material kind count. So based on the kinds. Where's this thing getting allocated then? Ah, right here. Property words count. Wait, why is it allocating like so many? That's dumb. Oh, that's an over allocation there. No biggie though. Are you making a game? Not quite yet. Building the engine part first, but eventually that's the plan. Probably not for another year or two, somewhere around there. Just getting the engine together, making some tooling, and then yeah, you do lots of prayer basically and figure out exactly what's the right thing to do. Yeah, lots of planning. You know, probably come up with like 3 different ideas, and lots of praying as well, figuring out which idea will be best, and also seeing something small that could possibly grow into something bigger. That's probably the best aim, I think. Um, raw material kind count. So yeah, you know what? The first one would be the geometry. That works. There you go. Now replace geometry with detail, then blend. This allows us to index into this map and get back how many property words, right? How many does this proto material need? So when we make a new material of this kind, say if you make a new brick material, it will index into this and be like, oh, the brick needs 4 property words, right? Well, it needs a lot more than that. It needs 12. So you can allocate a range of 12 words that can then get populated. You can store the properties and then read them out the other side. So, right, we'll need to go over. See the types? Yeah, I guess so. And then put them in here. Oh, that's a bit fiddly. Oh well. Right, so let's just copy paste this 3 times. Code could probably get written a bit better, but it's okay. We only have 3 different kinds. I think this will do basically. Always change it later if it makes sense. But for now, this one works alright. So blend, and then blend and blend. Alright, so we're gonna have a problem here if you overwrite with the same one, but that'd be fine. Right, you want the kind, that is very true. Alright, lovely. Next one is that when we allocate a material from the cache, we pass in a name hash, we get an ID back out. So that's fine, isn't it? It would be nice to know what kind it is, though. What kind of material this is, because yeah, it just would be nice to know. But yeah, this will work fine. Right, getting the number of property words though, that is used in. Oh, it is used in here as well. Yes, we do need the kind to be passed in somewhere. To be stored somewhere or passed in. Right, so if we take in a name hash, I think that's the way we're doing it. So we have a hash table which allows you to get the index, right, the proto material index. We could probably store the kind in there as well. Maybe store it in the low bits. This allows you to fish that out. Yeah, so I think we just shift left by 2 and OR on the kind, right? That should be good enough. Then when every time we retrieve it, which only is just here. So that would be the index, and the kind would be and 3, right? The 2 low bits. That can help. See, this function would actually so it's the kind and the index. So inside the material, we can actually store the kind as well. So when we get the number of words that a proto material needs, we also do need to pass in the proto material kind as well. Okay. So that will go. Now we don't we don't get a chance to do the bounds checking, which kind of sucks. We used to be able to do. So we could switch on it though, and still get to do that. Switch, right? Proto material kind. So case, right, so geometry, detail, and blend. Okay, so if we need just index via the kind. That should help. Wait for the compiler to catch up. Yeah, I need to address my compile times at some point, but for now they're right. But worse when it came to Windows. I think I still include Windows.h everywhere. Anyways. Graphics VK, material cache. Right, it's too many function parameters. Okay. So, second place is here in the store ops. Alright. Lovely. So, right, so the allocate. Oh, that's a kind index. Is able to fish out the kind. Oh, why has that not done that? And nice. This will go here. So it gets the number of words this material needs here. Brick needs 12 words. Right, allocates a range of 12. You get the block. Can't get it, return null. Right, we've got ways to tell whether or not it's a duplicate entry or whether or not it's failed to allocate. Then we allocate from the object pool, and then we simply populate all the parameters and off you go. The get doesn't change. Right. Store property. Yeah, so that hasn't needed to change other than this, which is cool. So we just got to change our usage code and then we can get back into the shaders and actually do some of that today, which would be awesome. So we can't really do the MOS at the moment. But yes, allocate a geometry material brick. Let's call it red for now, which is cool. And we'll comment this line out here, which is that one which is super close, which was the old moss that we had. That's going to be an added detail layer on top. So that's the other thing we've got to sort out actually is the we would like to probably change the mesh cache. Yeah, because we can only do one layer at the moment. We should probably add yeah, you know what, let's put them here. Yeah, we'll put them locally. Okay. Right, we're going to pass in an array into here. These are the material layers. And this should be generated from graphics VK encoder. Yeah, this layer count thing. Oh wait, of course you don't really need to do that, but C, isn't it? So, right, so 4 material layers. I think you can hint at it though. You say it points to a statically sized. Yeah, I think you can do that. Right. How do you do, right. Let's just ask the AI that'd be able to help us best here. So C point function arg or parameter. Wait. You just do array static. To, yeah, I think it's static. Then the thing you want. I think that's it. Pointed to array of fixed size. I think that's the static thing. Yeah. It must be at least 10 elements. That's what you want to do, I think. That means it must be on the stack as well. The other problem with it. But yeah, you know what? This is only test code, so it doesn't matter. Let's just do raw pointer. I don't think we need that is sphere anymore anyway, we're getting rid of that. Material layers. Yeah, so there. So we're gonna make it return a null. Oh crap, I messed that one up. No, I didn't. Material layers. Cool. So we've got to make sure that this function, this GPU material thing, so the get needs to be able to return a null handle. So I think this will end up crashing. So I need to say, hey, is this allocated? If it's not allocated, well, you'll get a null. Then this GPU one makes the GPU reference. If it's got a null, save material, great. Else, well, we could do the dot bit field equal 32. There's the invalid, isn't it? Name it GPU invalid. Yeah. Oh, right. So that should be everything from CPU side. And we would have changed the GPU side as well, so we can at least get the game back up and running. Now it's a case of like adding this detail layer. For some reason, yeah, it's got to be got to recompile the code gen basically. Great. Right, the code gen not handling this. I was going. All right. And take a quick break, and then we'll get back cracking at it. BRB. Right. Right. Welcome back, everyone. Like it kind of is. I don't know what's going on. Yeah, I don't know what goes. I don't. The audio coming through. Fan out. Fan out here. version for some reason. Right, so version. So file is this? Are you working now? Working now? How about now? Now you're working now, you're working now, you're working now, you're working now, you're working now. Seems to be working there, maybe now? What about here? We'll move my head back a bit. Work now, does it work now? Does it work? Okay, so it seems like it's cutting out every now and then again. Ah, it's a big old shame. I don't get it. Should I try my webcam or something maybe? Maybe that would be okay. But if I just keep talking like this, does it keep working or keep not working? Or yeah, maybe it's a threshold thing. Might be a threshold thing. Maybe. Oh, my son has came by. Press some buttons. But the problem is I don't know which button. Oh, wow. That just got way better. I did nothing. Hmm? That actually got louder again. Amazing. Yeah, so I think OBS, I've got a threshold limiter. And it didn't even press anything on my on my sound card thing here. And I sometimes you can press a button and it like brings the sound all the way down. And I think my son had pressed it, but I just literally touched it in my hand and it fixed itself. I have no idea what happened, but anyways, it's back now. Yeah, I guess so. That's a way of doing it. Thank you, sir. Radio. So which one is the brick? Oh yeah, okay. So right. So all we need actually is a better that parse file. So if it's DB. So But the problem is my I think the logging system wants to. Yeah, there's something up with the logging system as well. So I think we fixed the problem. It's just the log system in the encoder. Is it just not set up? So log. The file is 0. Yeah, so I don't think the log system's been set up. That's it. There we go. All right. There we go. So now it's not going to spam out. So yeah, basically it's going to say cannot find. Or maybe not. If it's not a database file, we cannot find it abort. Is that going to be a thing? Yeah, you cannot find. I guess the other one printed that out as well, didn't it? Oh, it did. It did. Yeah, yeah, yeah. Cool. So that issue is solvable by going into the build script. Then, yeah, so another problem as well. We've got to manually do these here, but it's okay. So geometry, detail, and blend. Right, so redoes the code gen. So cannot find const expression or VLA field layer count. Okay. So it's going to that encoder file. So does yeah, so maybe I didn't add support for enums to the encoder system. So I wonder why I never did that enum values for the as constants. So if you change the enum, that would then change the strut thing. Yeah, it's the same as a constant expression. So I wonder what you could do around that. Can we add support for that quick? So that would be array. Yes, it's constant expression value. So I think you can do an enum value as well. Every single time we have support for this. So type array string, so that would be cool. Next one. So if it's not, this is when we're parsing it. So if it's not an int, then error. Okay. So I think you've got to then find a value. Is there like an enum value? Hashes. Find value for a string ident. That's what you want, isn't it? Yes, so when parsing the array, guess we'll just do another one of these then. Okay. I don't want to deal with all these extra indents though, to be honest. And maybe that was the right move. Either an EV and a C. Cool. So when we're parsing it, the type table and then ident. Yep. So effectively, it always has to be a uint. We don't have that problem. And rather than constant expression, we just do enum. Then value. Number of elements is based on this. Okay, lovely. Very, very good. So we just keep looking for this constant expression value thing, see where else it's used, but I think that's basically it. Okay, so that should have added support for it now. Super cool. Right, so let's try and rerun that. Alright, what's it complaining about now? We got a crash. Oh, that would be let's give that another run. Right, we need some more parameters. Oh, did it compile? No, we didn't compile. Oh, it worked. I didn't see. Okay, so that would be a grab all these. Need to throw that into the um, arguments. Oh, we're crashing right here, are we? Ah. Excuse me. I've got to change all the C variables. Okay, this is great. So now we've got the code gen working. So the graphics material header is not compiling, neither is the source code. So let's sort out the source code first, I think. Right, so graphics VK shared generated. Let's look at that. Here it is right here, yeah? So yeah, the value is right there. So why can't we see it in? So that's included right at the top. It should be there. Maybe I need to just run it a second time for it to want to get it. No. Oh. So that's super bizarre. Okay, I guess we spelled it a bit wrong then. I don't know why then. I spelled invalid wrong, is that right? Or oh no, I spelled invalid right. I did graphics, whoops. Oh, I did GPU in the other one. Whoops. Okay, so that'll be graphics VK shared encoder. One of them was GPU. Okay, I fixed it. Cool. Next one. So 638. Get rid of these booleans on the end. That used to be, is it a sphere? We wouldn't do spheres anymore. Get rid of that. Right, so these wanted to, oh, whoops. We want to do graphics material ID arrays. Material layers. So the layer count. So for the geometry, layer, we're just going to do this test material. And then for the rest, we'll leave it alone for now. Cool. Right. So was able to compile there. Now just got to compile the oh, the game is failing to run, but the shaders are all messed up as well. But what's this complaint about when it's trying to run? So null ID. So cache get Right, so that is not allocated thing is not working. We should, when we get the GPU, if it's not allocated, then return null. So it's saying it's allocated? Is that asking, oh, okay. False 0 is allocated. Right. Okay. We're not really... Right, we're just checking if the index is allocated. Hmm. Yeah, that's a bit dumb. Let me sort this out. So... really should just be passing in the raw ID. And then... it's just an object pool, basically. So raw ID... So... you want to check if it is allocated. Should we be asserting? Yeah, to find invalid information, I guess we should. We want to get the index, and we would like to get the generation. Right, so we have debug assertions. Get the generation. If the generation is not equal, then right, so when you initialize, don't we set the first one to 1? No, so right, what stops you from getting... Right, so if it's equal to 0, we make it 1, but only when we allocate. Okay. Return false. Let's try this out. So maybe this is improvement. Right, still trying to do an object will get. I'm just gonna pop in the debugger. Right, so Let's try this one out. Huh. I pressed step into that, I'm pretty sure I did. Hmm. Okay, can we get into that function, please? Weird. Ah, you know what? It's not recompiled, is it? Hmm. So that would be... Okay. Interesting. Ah, I still got that problem in it. Okay. Let's just get into here. Put a breakpoint. I don't know why it's not stepping in. They're really gonna break out here. Yeah, I don't think it's got the latest code or something. Or what's this complaint about? Read only. No. Alright, give me some watches. I wanna watch that index. Looks a bit fishy to me. Right, I'm confused there. What's going on? So, don't mind me if I just come in here and delete the build. Right, let's try that again then, shall we? Oh. So the thing wasn't compiled. Right. Weird. That's why it's out of date. Okay. Right, so I think sometimes you want both. Sometimes you want an is allocated index, but other times you just want like an is allocated. Uh, yeah, okay, so right, let's get these two. No big deal. So there's an allocated index. One is an ID though, so it's an ID. Uh, wait a minute, why is one a... Why do I need a type safe wrapper? Yeah, I don't think you need the type safe wrapper, put it that way. You just need this. Is allocate index. All right. Okay. So we have both. When it comes to that GPU side of things, we just get rid of that, and I think it should work. Hmm. Right. So I think it compiled. It did. Good. 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 So what's left now is the shaders. Finally. So got some compile errors here for the shaders. So 5, 8, 9. All right. So this one's complaining because there's no. So I've separated out the ray march into a separate function now. So this will allow us to do this at lower resolutions in the future. Because it used to do the ray march and then the shading all in one go. So the problem is we've got to read out some properties from this material. So we read out the property words, right? Pack them into this structure. It's all code generated. Then we use the code generated unpacking code to then get these in here. So these are the things that we need to do the brick ray marching. So unfortunately, it does require a bit of setup. So we have to pass them into setup structure. We get the distance brick properties specifically for ray tracing or getting a distance or the time distance field of the bricks. So it's missing this ray direction ms, so in material space. So that used to, oh, cool. So that used to be, oh, we passed it in here now. Lovely. Yeah, we need to make it parameter. So it will now be vector 3 ray origin material space, vector 3 ray direction material space. Um, that's the thing then. It's like, so how do you, are you changing the, no, we just need to return a T. Where's the T basically? Is what we need to return is a bit of T. So ultimately we want to return the T. Cool. Right, let's see where that goes for now. Right, so we're missing 588, whatever that's complaining about. Oh yeah, we need to slap the word geometry before there, because we've had to give it a good old rename. Right, so the next one is 607. Right, so this one is like a discard, so we want it to discard, right? So we have not hit something successful, basically. So if we get a T, which is yeah, we want to know, like, was this Rain March a successful hit? So I guess you can return a Boolean, if you will. So if we've failed to remarch, then return invalid. Yep. So how do we know? So if your T is negative, right, we're going backwards or something, then return false. If not, return true. That means from this, when we return, we can just return a -1, symbolizing that we've failed to hit something. Well, we could return infinity. That's another thing. That might be a better thing to do. It's more consistent. So, infinity. Is infinite. So is, okay, it's cool. Lovely. Cool. Right, what else? So 614. So 614 says, what's this one complain about? Right. So, okay. We're trying to calculate like a normal now. So it's like, oh, we've hit a thing. Yeah, we've hit the bricks to calculate the normal, and I guess you know, you don't really want to calculate this just yet. You probably want to calculate that as you do the shading, I think, because we're going to be having different, we have a geometry pass, then you have a detail pass, and depending on which one you hit, you want to use that one basically. I don't think. Well, you could always calculate the normal on both of them, and then just keep the normal, the one that you end up using, but then it's a bit more expensive. But it's okay. Right, we'll think about this in a bit, but anyway, well, what's the problem to get it working? Oh, you need this, don't you? Okay. To get it back into world space. Alright, so in this case you get your T. Oh yeah, you can pass out the normal. You can actually make it pass out a vec4 of A or whatever you want to call it. just your values maybe, your v, and then I might do it. You want to return your vec. You don't do this until outside. Put that near somewhere. Radio. So your normal and return vec 4 t n. So right. So I guess here you can say, right, my t is v.x and my normal in material space is yzw. So so here we can set the surface. We can transform it here. So be normal in material space into world space. Right, so that's going to get us out of that trouble there, hopefully. So 607 now. What's this one complaining about? Okay. So it's using shading UV still, which is probably not a good idea, but right, so you just return a vec for infinity. Right, so it's using shading UV. So if we manage to step out of the bounds, basically, do we reject it or not? That is interesting. That should be universal to all the geometry passes. So we kind of want to take this with us. Hang on a minute. So kind of here is the new shading. So geometry UV, if you will. New UV shading.uv plus redirection times t. So we can call this the geometry UV. So this is why it's specifically tailored to probably being a cuboid, because then we can clamp if the UV strays outside of -1 to 1. Such that if you get Milton up, so say you've got this wall and we have some vectors in the vertices such that we can, it's kind of like a tangent and bitangent basically, such that we can, you know, the x-axis follows along the wall, the y goes up the wall, and the z goes like that way, yeah? So this would then mean this would be -1 in this corner here, and this would be +1 in this corner here. So if we have a ray that shoots through here, this wall, and say if it sort of goes near the edge such that it's a bit rounded so it kind of goes past into the background, we won't land and hit some bricks on the outside of the wall basically, because oftentimes we just repeat stuff along a grid, so that kind of helps there. Right, so that can be gone from here. So min hit distance. Um, so that's the distance away. There's outside. So if the last sample was outside by a lot, I'm not sure what a unit of one is it's in UV space, isn't it? I'm not sure we really need this, but we can double check that later on. Not fussed at the moment around that. So 648. Okay, so this is the shade brick. So the shade brick. All right, so this is another interesting thing to sort out. We want to pass some parameters from the ray marching pass, because now we've separated it, to the shading pass. So what I was thinking about doing is having just like an opaque structure of floats, and you're allowed to have up to maybe 4, or maybe I'll start with 2, is what we need, where it allows you to pass them between. So what we need access to is an OD brick. Distance to the brick. Do we use the distance to the border in the end? No, we never used it in the end. Why? Oh yeah, I see. Right, so we might want to pass geometry material shade brick. So from the shading, oh, it's not even not set up properly, is it? Okay, so right, so from this Raymarch pass, so I guess in the shading structure we'll just jam it in there, I think. So we'll call it shading. Let's go to shading. None of these passes in, they're all done internally. So these are this is gonna be called the geometry material these are things that you just pass from one stage to another. So I can just call them Raymarch hit attributes, if you will. It's a bit long. Or material hit attributes, let's just call it that. So let's just say there is 1 for now. We could do 2. Let's just do 2. So from Raymarch brick, you know, we've hit at this point. So we'd like to. Well, that's interesting. These half counts. We need that in the shade as well, actually. What is a half count? A vector 3. So we might need. So maybe just do a vec 4, right? So just call it attributes vec 4. Okay, back to the shading strut. Yeah, let's make it vec 4. So hopefully that's enough. So the basic idea would be that you do a shading dot vec 4, and you need to pass out what's known as O, so it's output distance to the brick. That needs to be passed. Nice. So now we just got to fetch those out from the shading side. Yeah, half brick counts, you could probably just recompute that, not gonna lie. That would be... Yeah, but I guess if it's already... Hmm. Right. You see, I wonder if that shading UV... Yeah, it's once it's hit. Okay, that's fine. Right, yeah, we'll just pull it out, it's fine. So... Right, so... It's known as distance to brick. That's just dot x, basically. And then we would like brick half counts as a vector 3, which is basically just YZW. AO. All fine. Right, see if that compiles. Right, 650 is nothing called O apparently. Oh yeah, dbrick. Cool, and then dbrick here. So if we're inside the brick, you color it this way. If we're outside the brick, it's just the border. We smooth step a bit of AO in there as well. Right, these are really being reduced right now, which is super cool. So there's this min hit T. Now, I don't know how we're going to do this because they're going to be kind of different for every single material. Sorry, every single geometry material. But they're also kind of like a, what's the way of saying it? They might be dynamic based on the kind of pixel. Oh, we might reject it if you go smaller than a size of a pixel kind of thing. So we'll early out at different ways. So, yeah, we'll find a way to remove this, right? To do, we probably want this to be variable. To be able to discard, to, you know, stop when we reach size of a pixel, something like that. And either determine that as a hit or not a hit, I forget. I need to think about it. But yeah, for now, right, so the MOS has its own, we'll leave the MOS alone. Right, so 835, we're nearly there. So this one's complaining because it needs to return a false. 841. Cool. What else needs to be yes? That would be Right, 872. Right, it's the same about returning a T. I don't think that he needs a T. Oh, seems like the last one. Ah, cool. So that returns a... Oh. Cool. So it all compiles now. Obviously, it's kind of broken. So we've just got to see what the problem is here now. So we've got a material store kind of crashed and died for some reason. So 211. Right, I think this might be a reasonable place to stop. Kind of getting late now, and yeah, so we're nearly there. So in the next stream, what we want to do is get this up and running, and then sort out the detail materials where we can actually try and get little moss bounding spheres placed down and write all that sort of code. So having an extra layer to ray march on top of basically, which would be super cool. Add some, yeah, can make the materials look unique and customizable basically, which would be really nice. But yes, the next stream will be on Thursday. That'll be at Thursday, 7:30 p.m. GMT +1 now, as the clocks have changed. And if you'd like to chat in the meantime, there's a Discord if you want to come hang out and chat. And there's also, if you'd like to support the channel, there's a ways to get access to the code to run on your own local machine, and also support the channel in this at the same time. I appreciate everyone who supports the channel and for everyone who came by today. Hope you have a good Wednesday. Hopefully see you Thursday. If not, there's a Friday stream and one on Sundays. You can check the schedule down below. All right, God bless you all. Hope you have a good week, and I'll see you all very soon. Right. Bye.